So when you look at 3.4, you're really reviewing a lot of 3.2. And so if we take a look at the first problem, we're going to use substitution. And substitution is already set up for you. We're just going to put this y equals x minus 1 to here. So it's literally going to go right there and become x minus 1 equals the other side of the equation. Then you just solve it for 0 like you did in 3.2. You move things over, and then once you move things over, you factor and solve. And in these problems, I'm going to have you factor a lot just to remember how to do it. But the problem is these aren't the answers in completion for 3.4. What they are is they're half of the answer. Now, what do I mean by that? In 3.4, you have points, and it says it right in this instruction, find points of intersection. And so when I look at these problems, what I have right now is I have 2 in the x position and I have -3 in the x position, but the problem is I need to find the y. And the way you find the y is to take 2 and put it in the original problem. If I put 2 right here, I would get 2 minus 1, and that will give me 1. If I put -3 in here, now I have -4, and that gives me the points. I mean, when you really think about what's happening in this problem, you have an equation that's a parabola, you know, it looks something like this, and then you have a line which is hitting, you know, maybe that parabola's in the wrong place, maybe the parabola's more like over here. And then you have a line that's going upwards and it's intersecting at 2 values, right? So you have a line that's hitting the parabola at 2 values. And so you found those intersection points without having to graph. So here you're going to do the same thing. You're going to move this over here and you're going to use the Gcf method because there won't be a C. So when you look at what happens here, right, I'll do the first step. When you look at what happens when you put this here, and then that equals 3x squared. I mean, and I think I've mentioned this in class, but it's very important to realize this, that at the very beginning, you can just do this. Anytime you have the same thing on both sides, they're going to cancel. So that way, when you subtract the 2x squared from both sides, and here you subtract the 5x from both sides, you end up getting a problem that has no C. And one of the things I think is important to understand is just little tricks to help you remember things. And so as you can see, there's no C. And so maybe that'll help you to remember to use the Gcf method because the Gcf has a C in it. There's no C, use Gcf. And that specifically is to take out the x and then set both pieces equal to 0. So you get x equals 0. Then you get x minus 3 equals 0. So you get x equals 3. Just remember that you have only found this piece. So you need this. And you've only found this piece. So you need this. Now, the next question is very similar, but notice what I did here. If you just blindly plug this in, you have to plug it in twice. That's a lot of work. Don't forget that you can algebraically manipulate this by simply subtracting 2 on both sides. And when you subtract 2 on both sides, this equation will become y equals x minus 2. And then it's just like doing the other ones where you put that there. Now, down here, we have to graph. I'm going to do the middle one because it has the strangest answer at the end. You're just doing chapter 2 stuff here. My vertex is going to be opposite h, comma k. Okay, so I'm just going to go to that point, which is at 1, 0. Don't forget that you're talking about the x-axis here, right? So don't put it on the wrong axis. And instead of doing 1, 1, when I have a 2, I'm going to go 1, 2. So don't forget that. And then I would go 2, 8, and then 2, 8 from the vertex, right? Not the point 2, 8, but 2 to the left, 8 up. And it's 8 because it should be 4, but I multiplied by 2. And don't forget here, my vertex is going to be 0, 2, because when there's no parentheses, there's no b or h. So I'm going to grab that one on the y-axis right here. You can see that intersection point. It's going to be important in the answer. We're going to go left 1, up 1, left 2, up 4, right 1, up 1, right 2, up 4. And then I'm going to draw my graphs. So here's this graph. And then my other one, which has been stretched, is here. And then what's important is to then go back and, you know, this one right here, it has an inequality that is telling me that I don't have an equal sign. So I need to make this a dashed graph. Okay. All right, so there we go. And then for this one, it is going to be shaded below. So I'm going to shade below this graph. And don't forget, it's going to be everything. And you could do this with horizontal and vertical lines too. I mean, don't forget that's also equally valid. And so once I do that, I can see everything that's below the blue line. And then to do the green one actually asks me to graph above. So if I graph above the green one, I can see the intersection here. It's this green thing. So if I do the domain, remember, we're talking about the domain. It goes this way, B, and it stops right there. I know that this goes on in infinity, but it's never going to the right, it's always going to the left. I had a student remind me of that, and I appreciate that reminder. In class, I might have said that was going to infinity, but if you look at in the range, it does, but in the domain, it does stop right here at this point of intersection, and that point on the x-axis is 0. And the reason it's not a solid dot is because if you have an equals mixed with a not equals, you have to use parentheses, unlike here, where I used a bracket because they're both equal signs. All right, so down here, we really get back into 3.2 stuff. Like when I look at this problem right here, you're really talking about 3.2, and you're talking about the square root method, right? You're talking about adding 20 and then dividing by 5, take the square root. And I'll tell you that you do get plus or minus 3. I obviously want you to see you do the work on your paper for when you submit it for homework. The part that's important is understanding that you don't know which way this goes. And if you keep the inequality in here, you typically get like a double to the right or double to the left, which we talked about being wrong in chapter 1. So I've introduced this number line concept so that you have to learn to plug something like x equals -10 in and check in the original problem, but you don't really need to know the entire answer, right? Like if you want to put -10 in here and know that it's 500 minus 20, that's 480 and that's less than 25 and that's false, that's fine. But you really just need to know if it's true or false. So if I put -10 in here, I get 500. Is 500 minus a little tiny bit less than 25? No. What I really care about is that you know it's false. If I were to put 0 in here, right? 0 is really easy because it just gets rid of this term. Is -20 less than 25? The answer is, yeah, -20 is a smaller number than 25. And then if you plug it into the last part, you get a similar situation to -10, right? And again, if I put 10 in here, and maybe it makes more sense if you use 100. Like 100 is 10,000 times 5. Is that less than 25? No way, right? And so you get an and graph. And so your answer is -3 to 3. And because there is no equal sign, we use parentheses. Now, the next one here, we're going to use brackets. But this one is a factoring problem, right? So if I set this one equal to 0, and a lot of students ask me, why, Mr. King, are you setting this one equal to 0, but you didn't do it on the last one? Well, remember, when you only have one variable, you just reduce the order of operations to take the square root. But when you have two variables, you have to factor it. That's just stuff that we learned throughout the chapter. If you really want to review something for this chapter, go back and do 3.2, all the ones that were hard. Now, this one's going to factor. You're going to get two answers. If I remember correctly, you get x equals here. So you do the work. So you're going to get x equals -4. Actually, I think you get it in the other order usually. So you're going to get x equals 2 and x equals -4. And so let me just factor to make sure I don't have this factor backwards. So this would be x2 and 4. And then you want it to be negative. So that would be negative, and that would be positive. So when you set up with a 0, I had that backwards. I'm glad I double checked. Okay, so make sure that the middle term comes out right. Then you're going to check it on a number line. Make sure you put it in order. This right here would be bad. If you did this, your answer is going to be wrong because you don't have the right. You got to put it in ascending order. That's true for everything in algebra. And so you're going to check again. You're going to check -10, and you're going to check 0, and you're going to check 10, and you're going to tell me what you get. Okay. Now the next one is another factoring one, but we don't want to subtract the x squared to make it factor because we'll have a negative coefficient. So we're actually going to move everything over here. And then I just want you to stare at it so you don't mess this up when you take your assessment. So give me a second to write this out. And so here you have 0, right? And then here you have 3x squared plus 12x. What do you not have? There's no c. So you GCF, right? Now, when you GCF this, you're going to get two answers. One of them is going to be 0. The other one's going to be -4. So when you put this on the number line, make sure you put it -4 and 0. And I just want you to think about this. You can still use -10, but can you use 0? You can't. You have to use -1, and then here you're going to use 10. Okay, and you're going to check them in the original inequality. And again, it's really easy to check if you just think through it. If I take -10, here I get something positive. If I take -10 here, I'm going to get something negative. So is something negative greater than something that's positive? The answer is no. So just make sure you're checking the correct answers. Maybe you start with the easiest one. Maybe you check -1 first, right? That might help. This one will factor using the box method, which is a great thing to review. If you need help with that, make sure you go back and look at 3.2 and do some box method problems. This one you solve by reversing the order of operations. You do get integers, so that's not a very hard one to do. And then there's number 12, which number 12 does not factor. Like try to set it equal to 0. The box method doesn't work. I mean, think about it. 2 and 4 are never going to add up to 14, right? They're going to add up to like 10 or something else. But 2 and 4 don't have the factors to get to 14. So I factored the 2 out. Okay, I factored the 2 out of there. And I guess technically, let's be honest, maybe you should subtract this 4 in this step. So I'm going to put that there. And then you factor the 2 out. Let me just restart that because I feel like that might be confusing. So it doesn't factor. And if it doesn't factor, we need to complete the square. That's why I wanted to back it up. I feel like maybe you didn't know why I was doing that. It doesn't factor. So you're going to subtract 4 on both sides. Now, let me ask you this. How would you know it doesn't factor rather than just using some logic? Don't forget the discriminant would tell you it doesn't factor as well, right? So if you can't figure it out, if you do the discriminant, if the discriminant is not a perfect square, it's not 0, 1, 4, 9, 16, 25, 36, and so on, then you know it doesn't factor. This is what I think you can logically tell because 2 and 4 cannot add up to 14. I tried to make it obvious. So when you complete the square, you're going to take the 2 out. That'll give you a, oh, I see what I did there. Sorry about that. 6 and 14 is 20. That's why I had that 10 on there earlier. Thank you for bearing with me. Okay, there we go. And so here we have a 10, and we're going to complete the square with a 10. And so to complete the square, it does help to write it out. To find C, you're going to do 10 over 2 squared, which is 5 squared, which is 25. So you put the 25 here, you put the 25 here, and I'm going to let you finish that one up. You do get these answers, -5 plus or minus 3√3. Once you've broken down the radical that emerges, that is the answer you get. Just don't forget here, I almost made a boo-boo that that's actually 25 times 2, right? Because don't forget that this is being distributed. So even though you add 25 here you have to balance it, and then you will get my answer once you finish the rationalization of that. So this one is harder than you'll see on a test. And what this one is getting at is that like these answers are nutty. So that's why the number line is so helpful, because if you write these out, right, plus and minus 3√3 would be minus 3√3 and plus √3. If you type these in a calculator, don't worry, on the test, I'm going to give you integers or simple fractions like a half or a fourth. I'm just trying to get you to think more deeply on this formative so you understand how this works out in general. So this is actually -10.19. So I use -100. And if I put -100 in here, I get 20,000. Is that going to be less than -14 times -100? The answer is 20,000 is always going to be bigger than whatever this is. So that's false. Again, you might want to start where 0 is, because you just get 0 is less than 4, which is true. And 10 results in a similar thing. But how do you know 10 is even in the interval? That's why I use the decimal, right? So this thing, -5 plus 3√3, is actually 0.19, so 10 will work. And that's why I couldn't use -10 here, because -5 minus 3√3 is actually 10.19. So if I pick -10, I'm actually over here. I need to go bigger than -10, so I pick -100. All right, the key to this assignment is review, review, review. Have you done 3.2? Do you know how to factor? Do you know the completing the square method? Notice I did not use the quadratic formula. I could have on this problem, but the quadratic formula, as you learned, is a mess. On the test, I will tell you on 3.2 only to do it. In general, what matters more is the square root method, the GCF method, the box method, and as you saw over here, factoring all over the place, right? So factoring is the most important thing moving forward. And factoring is the thing you're going to see in every chapter in every math class from now until the end of time in math classes. So I hope that helps, and I hope that you study hard.